You know, almost every single thing you do online, from sending a quick message to streaming a whole movie, it's all powered by one single fundamental concept. And today, we're going to break that concept down, the client-server model. I mean, it kind of feels like magic, doesn't it? You tap a button and boom, new information just appears on your screen. But behind that one simple action is this high-speed conversation happening between your device and a computer probably hundreds of miles away. By the end of this, you'll know exactly what they're saying to each other. And at its heart, it is that simple. Just think of it like a dialogue. One side asks for something, and the other side goes and gets it. This basic request and response pattern is the engine that drives the entire modern internet. It's so elegant, it's incredibly powerful, and trust me, it is everywhere.
Okay, so to really understand this conversation, we need to properly meet the two key players involved. Let's break down who they are and what their jobs are.
The best analogy is a restaurant. The client is you, the diner. You're sitting there at the table, you've decided what you want, and you're the one who makes the request. The server? That's the kitchen. It's this powerful behind-the-scenes operation that takes your order, does all the hard work, the processing, the cooking, and then sends the finished dish right back out to you. The client initiates, the server fulfills. You use clients all day, every day, probably without even giving it a second thought. Your web browser, whether it's Chrome or Safari, that's a client. The Instagram or WhatsApp app on your phone, oh yeah, that's a client too. Even some of the tools the developer uses on their command line can be a client. They're all just applications designed to ask for stuff. Now on the other side, you've got this whole team of specialized servers. A web server is kind of like the front of house, serving up the basic web page. An application server is the real brains of the operation, running all the complex logic. And the database server, that's the archivist, totally focused on storing and retrieving data. Each one has a critical role in fulfilling that one single request from the client.
So, we've met the dancers, our client, and our server. Now let's look at the actual steps of their little dance, the request-response cycle.
This conversation always follows 4 main steps. First, the client has to open up a line of communication. Think of it like dialing a phone number. Then it sends the specific request, usually with a protocol like HTTP, saying something like, "Get me this web page." The server then does all the heavy lifting, processing that request, maybe talking to a database, and finally, it packages up the result and sends the response back, and the loop is complete. The wild part is this whole cycle can happen in milliseconds. But here's the thing, not all of these conversations have the same rhythm. These digital chats can be synchronous or asynchronous, and knowing the difference is absolutely key to building apps that feel fast and responsive. Synchronous communication is the most straightforward way. Just like the example says, the client sends a request and then it just waits. It's a blocking operation. Nothing else happens until the server sends that full response back. It's like making a phone call. You're totally tied up until the conversation is over. So here's the trade-off. Synchronous, on the left, is like a single conveyor belt. It's simple, yeah, but you can only handle one thing at a time. The whole system is blocked. Asynchronous, on the right, that's more like a multi-lane highway. You can send out a bunch of requests and they'll just come back whenever they're ready. It's a little more complex to manage for sure, but because it's non-blocking, it is way more efficient for pretty much all modern applications. Okay, so we've pretty much covered the how. Now let's get to the really important part, the why. Why is this simple model so incredibly powerful that it underpins our entire digital world? Well, the power of this model really comes down to its ability to scale. A centralized system of servers can be designed to handle requests from millions or even billions of individual clients. This massive one-to-many relationship is the architectural secret behind global services like Google, Facebook, and Amazon. And that scalability, that's just the beginning. By centralizing the server side of the whole equation, you can manage things much more effectively. You can just add more servers to handle more traffic. You can enforce security from one central place. You can use caching to make things feel lightning fast. And you can build in backups, so if one server fails, another one just takes its place. Let's make this super real for a second. When you open Netflix, your app is the client. It sends a request, "Hey, I want to watch this movie." Netflix's huge, globally distributed network of servers processes that request, finds the video file closest to you, and streams it back. This is the client-server model operating at a truly breathtaking scale. Now, while this model is definitely the dominant one, it's not the only way to do things. And, like all great ideas, it has evolved over time. The main alternative you'll hear about is the peer-to-peer or P2P model. The key difference is just one word: centralization. In the client-server model, you have a central, powerful server managing everything. But in a P2P network, like BitTorrent or blockchain, the whole system is decentralized. Every computer in the network acts as both a client and a server, sharing the workload directly with each other. And even within the client-server world itself, things are constantly changing. Instead of one giant monolith server, modern systems often use microservices, breaking that one server into dozens of smaller, specialized ones. Technologies like serverless and edge computing are even changing where that server code runs, moving it closer to you. But no matter how complex the architecture gets, that fundamental principle stays the same. A client makes a request, and a server provides a response. So, as we start to wrap up, what's the one thing you really should remember from all of this? Let's boil it all down. It's all about the advantages you get from separating those two roles. That separation gives you centralized control for easy management and maintenance, it gives you a clear path to scale up, and it gives you a single point to enforce security. This is exactly why it has become the absolute foundation of modern computing. Of course, no model is perfect. The biggest drawback here is that if your central server goes down, the entire system can fail. And it also relies heavily on a stable network connection between the client and the server. It's a trade-off, but for most applications, the benefits have proven to be more than worth it. And that really is the bottom line. Whether you're building a simple website or a massive distributed system, it all starts right here. Understanding this fundamental dialogue between a client and a server is the first and most critical step. So the next time you tap refresh, you'll know you're not just getting new data. You're kicking off that elegant, essential dance that makes our digital world turn.